Hello, Zika, my voice audible to you now? Am I audible? Hello, hello, hello.
Yes, sir. Now you're audible.
So I think I don't know what happened. I mean, the Zoom simply logged out. It showed DNS error, and it was not connecting at all. And I was trying to find the issue. Then I realized that the issue is the hotspot. So
Okay, sir.
after that, I reinstalled. Meanwhile, I reinstalled everything. Okay. Anyway, so we can now start doing the problems which are based on the BITSAT law. So we can write application of So what I'm going to do is I'm going to make you host. Okay. So you can save the, I think, video also.
I'm not really sure about how to say that.
Okay, then leave it. Not an issue. Not an issue. Hopefully things will be fine. Okay. So the first will be like calculation of B due to V means magnetic field induction due to current carrying straight conductor. Okay. So what we have here is a part of circuit. So we are not showing the remaining part of circuit, and this part of circuit is carrying current I. And of course, everyone will contribute. What we are only interested in, what is the contribution of this part which I am showing here at a point P here. And if I draw a perpendicular from this point to the wire, this will be the perpendicular separation, and the ends of this segment of wire which we are interested in subtends an angle alpha and beta. So first of all, if the current is moving towards up direction as shown in the figure, at a point P, the direction of field will be into the plane or out of the plane, or what will be the direction of field?
Sir, into the plane.
Very good. So it will be cross field, right? And no matter which elementary we choose in the given segment, every elementary will contribute in the same direction.
Yes.
And because every elementary will contribute in the same direction, so the vector addition will turn out to be a simple scalar addition, because direction is not the issue, right? So again, the way we have approached a problem in electrostatics, the same thing you can do it here also. So first you draw the wire segment, and as usual we draw the reference line, the perpendicular. So the perpendicular will act as a reference line. You can extend this reference line. And in electrostatics also we have done. So we can move from the reference by Y, and then we can decide to cut the dy. Okay. And let's say this the dy element subtends some angle So let's say this is theta and the angle it's subtended, that's called d theta. And the separation, the distance of the dy from the P point is r. So the dl vector will be in which direction? So the dl vector we take in the sense of current flow, which is upward, right?
Yes, sir.
So the dl vector will be like this, and the r vector will be away from the element taken. So what is the angle between dl and r vector? Can you guess the angle?
5 minus of theta plus d theta.
So what is the angle? This is the angle, right?
Yes, sir.
And how much is that? It is the exterior angle of a triangle, so we can say this is 90 plus theta.
Yes, sir.
So if you use the BITSAT law, so in scalar form, how we write mu naught by 4 pi I into dl cross r. So what is the dl cross r? It was dl sin theta, correct?
Yes, sir.
What should I write here?
Right. Sir, we should write DLR cos theta.
No, where is the dl? We don't have dl here. We have dy.
Oh, yes, sir. DY R cos theta.
Where is it? So r we can cancel from that will be r square,
Okay, sir.
right?
Yes, sir.
And because this is d separation given, so can we convert everything into in terms of theta angle?
Yes, sir.
So you know how to convert it into theta, right? We have done this before many times.
Yes, sir.
So tell me how to do this.
Sir, R cos theta is equal to D. So
Correct.
D sec theta is equal to R.
Correct. And still the dy is left, right? How to get rid of dy?
Why? Sir, so we'll consider RD theta as dy?
No.
No, because it's like a
R d theta is always a perpendicular like this.
Oh, so you will take a component of
Yeah, so that will be like
RD theta sec theta or cos?
so this is basically 90. This is like 90. This is 90 minus theta, right?
Oh, yes, sir.
So this
That
will
will
be
be
theta.
theta.
This will be theta 1. So dy cos theta is r d theta.
Yes, sir.
Okay. So basically, you can say dy is r sec theta d theta, right?
Yes, sir.
But r itself is the d sec theta, right? Yeah, we can see r itself is d sec theta.
Yes, sir.
So the dy turns out to be how much? E sec square theta d theta, correct?
Yes, sir.
No, this was not required because see, I mean, to get the elementary relation, you first get the relationship between y and theta. So we could have written. So alternatively, we would have written tan of angle theta equals to y by d. So y turns out to be how much? T tan theta. And therefore dy by d theta equals to d sec square theta. So we got the same, right?
Yes, sir.
or of course the dy cos theta itself is r d theta. So we could have substituted here also the direct replacement, and this could have given you dv equals to mu naught by 4 pi I r d theta by r square, right?
Yes, sir.
Now this formula is very interesting, and this can use directly. So this is I d theta by r, right?
Yes, sir.
So what is interesting here, that what really matter is what is the angle subtended by the elementary which you have taken. It really doesn't matter what is the length of the elementary. Okay. So the contribution of every element, we can think this way, it's a mu naught by 4 pi I into angle subtended upon separation. Okay.
Yes, sir.
Now here r is a variable because for every elementary, the r won't be same, right?
Yes, sir.
And therefore we must replace r in terms of the angle theta to be able to derive it. So
Yes,
we
sir.
can, we know r we can replace by d sec theta.
Yes, sir.
So I think pretty much it is straightforward. You know what is the next step.
Yes, sir.
So you can write here dv equals to, no, again remember the way I'm saying, dv is always equals to mu naught by 4 pi, which is the like the constant, then I into angle subtended by separation. This is the best way to remember the answer. And the r we can write as d sec theta, right?
Yes, sir.
Now this becomes pretty much simple, mu naught I by 4 pi d, and the sec will become cos theta. Now we are not writing in vector form because we know every elementary will contribute into the plane at a given point. Therefore, the direction contribution into each element turns out to be same, and therefore we can just integrate to get that net contribution. So the net field will be integration of dv, and therefore you can write as mu naught I by 4 pi d cos theta d theta, and that theta will go from where to where?
Sir, minus beta to alpha.
Now, if you realize that although we are coming across a new chapter, but most of the calculation and the process of taking elementary remains the same, right?
Yes, sir.
So always keep in mind that only formula changes, but most of the derivation remains same. So
Yes.
this will be your answer, right? So the B
Yes, sir.
equals to mu naught I by 4 pi d sin alpha plus sin beta. Okay. Now once you derive the formula for like this wire, and if I ask you what will be the answer for this wire in which the point is here, and of course the point is not in front of the wire, it is somewhere off the wire, the segment at least we are considering, and therefore if I extend the line to draw the perpendicular, I need to extend the wire also, right?
Yes, sir.
So only by extending the wire and the line we can get the perpendicular. Now we can assign the d, and when it comes to the angle subtended, we can draw the line joining from P to the beginning of the wire and the end of the segment.
Yes.
So
The
beginning
limits
to
will
end.
be from plus beta to plus alpha.
Yeah, very good. So you know the B at this case will change as a formula mu naught I by. Now everything remains same. Now it becomes sin alpha minus sin beta, right?
Yes, sir.
I hope you remember this.
Yes, sir.
Okay. So once we know this derivation, we can solve a variety of questions. So first of all, I'll draw a triangle to begin with. So we have an equilateral triangle. Carrying current in a clockwise sense. The side length is A for each side. And we are looking for the magnetic field at the center, which will be the centroid in this case, of course. So find B at okay. So questions clear? You can do this.
Yes.
Yeah, try this. So a small hint is because we have 3 wires, all wires are symmetrical. You find for 1, multiply by 3. That's it.
Yes.
And what will be the direction of B at this point C? Into the plane or out of the plane? Can you guess?
Sir, I think it will vary. Or I'm not sure. Oh, no, so it will be into the plane only.
Yeah. So as you move across the triangle, the point will be always on the right.
Yes, sir.
So for every element, it is on the right. So for right, it is always the cross field, right?
Yes, sir.
On the right of the current, we have the cross field.
Yes, sir.
And in case of confusion, you can remember this phrase, red cross. The right is always cross.
Yes, sir.
Then left will be dot without saying. So if right is cross, the left is going to be dot.
Sir,
Okay, tell me.
sir, I'm getting 3 root 3 mu naught by 4 pi d. I mean, d being, I guess, a by root 3.
So 3 root 3 mu naught I by.
Sir, yes, sir. Sir, I'm converting d into a form. That's
Okay. Okay. So you can find the B due to any one wire, and
I'm trying it.
So B1 you can write as mu naught by 4 pi I by D, and now D is something which we need to calculate or evaluate.
Yes, sir.
So you can add tan 60 as D A by 2D, correct?
Yes, sir.
So D turns out to be A by 2 tan 60, which is A by 2 root 3, right?
Yes, sir.
And then we have sine 60 and sine 60, which is 2 sine 60.
Yes, sir.
Okay. So D1 turns out to be how much?
9 mu naught I by 2 pi D.
So we have 3, 2 just 6. It's 6, right?
1 second, sir. Sir, multiplying it by 3.
We'll do it, of course.
Yes,
So
sir.
as of now, we are getting, let's say 3 mu naught I by 2 pi A, right?
Yes, sir.
So B becomes how much? It's 9 mu naught I by
2 pi.
okay. So of course you can do it for again a square, a pentagon, hexagon, and so on. So instead of doing all, we can directly look for the polygon. To find B at the center of n-sided regular polygon. Of course, current line. So that question is obvious. I mean, so we will not take care of the other side. Just look at the only one side, and the center will be, let's say, somewhere here. Okay. So this is the center. So what we'll do next is we will drop a perpendicular, right? And once you drop a perpendicular, what you need to know further is that the angle subtended by one side at the center. What is this angle?
Sir, pi by n will be.
Very good. So each will be, this will be pi by n.
Yes, sir.
Very good. So I think that is sufficient for you to understand the answer.
Yes.
BC equals to n times B1, right?
Yes.
So you find B1 and then multiply by n. That's so try this one.
Yes. Sir.
Yeah.
Sir, I'm getting n mu naught I by pi a sine pi by n tan pi by n.
So you're getting mu naught n I
Yes, sir. By pi a
pi a
sine pi by n tan pi by n.
like this.
Yes, sir.
Okay. All right. So so now what is a circle? If you think what is circle, circle is a something
Right.
with infinite polygon, right?
Yes, sir.
If it treats circle has infinite polygon, then can we prove the magnetic field due to the circle at the center? Using the polygon formula, can we prove the B due to circle?
Yes, sir.
The question is using okay. So try this out using that formula. Of course,
Okay.
we will derive it separately.
Yes. Sir, I'm getting mu naught I by 2R.
So that's the right answer. Very good. So how you remove the A?
Sir, by applying limits and A got cancelled, sir. I applied n tends to infinity and
Yeah. Then
sir, then like sine pi by n tends to 0. So I multiply the numerator and denominator by pi and removed the sine term. And then tan of pi by n is a by 2d. So
Mhm.
d is basically r. And if I
Yeah.
substitute that, then a and a will get cancelled.
correct.
So
So basically, you can also think that's a really good, very good. The other way of thinking is that the total number of sides will be n, right?
yes, sir.
And length of each side is a.
Yes, sir.
So the entire circumference will be pi na, and
Yes,
na
sir.
must be equal to 2 pi r, right?
Yes, sir.
So that will also give you the same answer, but it's really good you got the answer to that matter.
Okay, sir.
Just give me 30 seconds. Okay. Now you can do some questions like, what if the var becomes semi-infinite? Same similar thing, like current carrying var is there, and we want to know the answer at a point which is at one of its end. The other end is at infinity. What is the b value? Am I audible?
Yes, sir.
So b will have, okay, b is how much? Yeah.
Sir,
Pardon?
it will be mu naught I by 4 pi, sir.
Yeah, 4 pi d.
Yes, sir.
Okay, fine. So if it becomes infinite, then
Sir, that means it will become mu naught I by 2 pi d.
yeah, right. So if it is infinite, then it will become 2 pi d, right?
Yes, sir.
Now, these are some famous answers which we should remember only instead of deriving. I mean, this is pretty straightforward. Because you will get a question in which you have to apply this formula to direct result to get the other answer, right?
Yes,
So
sir.
I'll come to that. I'll come to that also. But before that, you have to solve some interesting questions. Not straightforward. So let's say we have again, I have given question like this, but in electrostatics with a different formula. But here the current carrying var is like this. Up to infinity, this is theta, this is a comma 0. So you have to find the b at O, right?
Yes, sir.
You know what to be done, right? Let's go ahead.
Okay. So here, do we like use a direct formula and then apply, I mean like, and then we make the components?
No, here component, you see, for the entire wire, current I, let's say the I is current. The point O is on the left, so the net field is going to be dot only, right?
Yes, sir.
You have to just use the formula, no? Extend the line.
Oh, right. Yes, sir.
You know this method, right?
Yes, sir.
And this is 90 minus theta, right?
Yes, sir.
And the other end is at infinity, which means that other end is at 90. Okay.
Yes, sir.
So the formula is simple, no? Formula is mu naught I by 4 pi t. The DOP
Cos
calculator
theta.
into sine 90 minus sine this. Sine 90 minus sine 90 minus theta, right?
Yes, sir.
So mu naught I by 4 pi and D is A sin theta, right?
Yes, sir.
And this is 1 minus cos theta. So you know how to solve question like this. We have done this before again.
Yes, sir. I forgot about the technique.
So you can further simplify if you wish. So it becomes 2 sin square theta by 2 upon 2 sin theta by 2 into cos theta by 2. The half angle formula, and then one will cancel out. And this becomes tan. Okay. So mu naught I by 4 pi A tan theta. That's the net D at O. Okay. Okay. This is I hope this is clear.
Yes, sir.
The next question will be so these are this is one infinite bar which is bent in a shape like this, which subtend an angle theta at the vertex. Okay. And from the vertex, we draw one angle bisector. So if the angle bisector represents a point P, and if the wire is carrying current I, so we are supposed to find the B at P. Okay. Questions clear?
Yes.
Try this out.
Sorry, I'm getting mu naught I cos theta by 2 by pi r. So,
Okay, sorry. How much you are getting? Answer.
sir, I'm getting mu naught I cos theta by 2 by pi r.
Like this.
Yes, sir.
So let me confirm it. It should be mu naught I by 4 pi. The D is R sine theta by 2.
Yes, sir. Oh. Sir,
And then-
it's r cos theta by 2, right? Oh,
No,
no, it's sine theta by 2. Yes.
And this becomes R cos theta by 2, right?
Yes, sir.
Because this is 91 theta by 2
Okay.
into 2 times, right? Because we have 2
Yes,
R's.
sir.
So mu naught I by 2 pi R. And 1 plus cos theta by 2 we can write as 2 cos square theta by 4. And the sin theta by 2 we can again write as 2 sin theta by 4 into cos theta by 4.
Yes, sir.
So the final answer is mu naught I by 2 pi R cot theta by 4. Right?
Yes, sir. Yes, sir.
So I think you missed the part of D, right?
Yes, sir.
Okay. Just. So let's do the next question. Sometimes the point at which you are supposed to find the magnetic field won't be in the same plane as the wire. So what if the wire is like this? So I will take the wire in the XY plane, carrying current I, and it is of course infinitely long. And the point at which you are supposed to find the magnetic field is in the Z axis. So the point here is here, which is 0, 0, that's called Z. So find B2. Okay. So current is going in wire kept in XY plane. Okay.
Yes, sir.
So try this out. See how much you are getting now.
Yes, sir.
Yeah. Go ahead.
Sir,
Yeah, tell me.
sir, I'm getting mu naught I by 4 pi z I cap plus mu naught I by 4 pi z j cap.
So I will give you like this.
Yes, sir.
This is due to the I, right? X1. And Y will give you towards right.
Yes, sir.
So the B at P will be mu naught I by 4 pi D. D means Z, right?
Yes, sir.
And I can say I cap minus I cap plus J cap, right?
Yes, sir.
So
The
what was the
current is
answer?
in the opposite direction, sir.
Yeah. The answer is
No,
different.
no. Sir, y minus I cap.
For Y axis. No, it's plus I. My bad. It's plus 1.
Okay, sir.
Plus I plus J. Just get one. This is your answer, right?
Yes, sir.
Okay, very good. So imagine if I gave you a question like this. There are two infinite wires. And these two wires are in the XY plane. And these are infinite wires carrying current I. Let's say this is carrying I1, this is carrying I2. Question is find the locus of points in the XY plane at which the B will be 0. Question is find locus of points at which B equals to 0. Think about it.
So I'm getting y is equal to minus I1 by I2 into x. Sir, I then.
Got the answer?
Yes, sir.
Yeah.
Sir, I'm getting y is equal to minus I1 by I2 into x.
Y equals to?
Minus I1 by I2. Yes, sir.
I think that's correct. So you can choose any point P, right?
Yes, sir.
So if I change this is xy, so B at P will be how much? Me not I1 by Y, right?
Yes, sir.
And it is on the right, so it's cross, no? So both will add up actually.
Yes, sir.
I think that's the right answer. Minus. Very good. Now you will get many questions based on the infinitely long wires. So now we have two wires which are infinitely long, but the direction of current in the wire itself is into the plane. So the wire is pointing normal to the plane actually. The first wire is carrying the just so we have two infinitely long wires carrying current, let's say I each. And when we draw the wire like this, it means the current itself is into the plane, and we have to treat as infinite wires. Okay.
I
And the
don't
coordinate is
exactly understand. Oh,
so
so
the
like
wire is
there are,
into the plane.
oh,
If
the wire are the orange points.
this is the wire,
Yes, sir.
understood?
Yes,
So wire is that's the direction of current actually.
sir. Okay, sir.
So from this infinite wire, the current is towards you, and for this it's away from the left.
Oh, yes, sir.
Let's say the coordinate is a comma 0, and we have a coordinate. We have a point here which is 0 comma root 3a. Okay.
Okay, sir.
Find B at. Okay. So try this out.
Sir, can you just come back in a minute?
Yeah, sure, sure.
So,
Yeah.
yes, sir. Sir, I'm getting mu naught I by 4 pi A as the answer.
This much?
Yes, sir.
Let me check. So first of all, the point P itself is, this distance is the normal to the wire, right?
Yes, sir.
So these two lines are mutually perpendicular to their respective wires, right? So if this is R, this is also R. So let's call it R. Now the B at the point P, due to the first wire, the left wire will be at its cross, so it's towards the right downward, right?
Yes, sir.
It's difficult to draw because I'll
They're
just go
like
like this.
60 degree.
Yeah. No, this will be 90 to the wire, no?
Sir, it will be 90 to the wire, but then 60 degree to the y-axis.
Yeah, right. That's correct. So this angle is how much?
Sorry,
Uh,
that's 60.
This is 30. So this will be 60, right?
Yes, sir.
Let's call B as now. And the red one will have the B, it's a dot field. So it is downward, right? Like this. Correct?
Yes, sir.
Just for ambiguity, I'm drawing it slightly bigger. And it is again 60 degrees, right? So the net is how much? 2B cos 60,
Yes, sir.
which is simply B, and B is mu naught I by 2 pi R.
Yes, sir.
And R is how much?
Eh,
R is how much?
Sorry, 2A, sir.
R is 2A. Ah, right. Oh, that's why you got the answer. 4 pi. Very good. Okay, so what I'll do, I'll give you some, before I go to the next concept, let's derive this formula quickly, and so that you can solve a variety of questions. In fact, you can solve any question. So, calculation of B due to current carrying at its center of curvature. So you can use the BITSAT tool again to derive it, and this time it's a easy derivation because every element you will take, the distance is same, right?
Yes, sir.
So the only variable, if you remember, the way to integrate was simple. So you move you can go from there by theta, you can cut d theta. Theta. So dv will be how much? Mu naught by 4 pi I by R, right?
Yes, sir.
Into d theta, if you remember. Because it only depends on what is the angle subtended by the arc length, right? So we know
Yes,
the
sir.
answer. And here the only variable is d theta, everything is constant.
Yes, sir.
So the integration of this will give you alpha.
Yes.
This is the simple answer. And for any given angle, you can find the answer. If you put alpha equals to pi by 2, we'll get quarter ring, pi by pi, then half ring, 2 pi, then full ring, right?
Yes, sir.
So B at the center will be how much in this case?
Sir, in this case, it will be mu naught I by 2 pi.
Mu naught I by,
Sir, 2
2
R. Yes, sir.
right?
Yes, sir.
Now, what you can do is you can start solving from Eurodov, and every question which is based on the calculation of B in a plane, only those questions you can attempt. And in the next lecture, I'll give you the idea about how to solve other variety of questions. Why I'm ending the lecture today now, because I have a lecture from 8:30 next lecture. And
Sir, can you just tell the numbers from which I have to solve?
okay, just a minute. I haven't brought the book here because I'm actually not in Mumbai, so I'm somewhere else. So I just haven't bought this. Okay, anyway, let me find. It should be in my.
Sir, I'll send you the PDF.
Yeah, yes, you send it. I should have the book out. Yeah, I got it. I got it. I got it. It is also PDF is with me also. Oh no, you send me. This is the different book. Yeah, I got it. I got it. Leave it. Leave it. Got it. So this is the page number. Can you tell me question number?
Okay.
Like question number of that chapter. It begins with 3 point something. No? Yeah.
Yes, sir.
Okay.
Yes.
Yeah, I got it. I got it. Yeah, just I'm almost there. Okay, so you can solve question number 3.2192, 3.229,
Okay.
and you can solve question like 3.245. And you can solve question like 3.258. No, no, no. Okay, that one.
Sir, 3.258 also.
3.258 you can leave. Leave that one.
Okay.
And I think I should have given you more questions. Just so you have this that na Ashish Mishra book.
Sir, Anurag Mishra, sir.
No, no, yeah. So in
Yes,
that
sir.
book, if you open the magnetism chapter, you'll get a lot of questions for practice.
Okay, sir.
So try from there also. Okay.
Yes, sir.
All right. So this week will be a bit of disturbance because of the Raksha Bandhan, I came to my hometown. So I will be returning on 15th of August. Yeah. So some network issue is very common here. I'm able to take the lecture. That's a big deal. Okay. Anyway.
Yes.
Good night. Take care.
Good night, sir.
So
Thank you,
next
sir.
week, next lecture is on which day? Like next lecture is next week, no?
Sir, on Monday, sir.
Monday. Yeah, fine. Okay.
Okay.
Okay. Bye. Take care.
Bye, sir. Thank you, sir.